Today we look at prime and composite numbers. We have our first 5 prime numbers on the left hand side. On the right hand side we have our first 5 composite numbers. Can you notice anything? I'll give you a little clue. Think about factors. Now if we list the factors, let's look at 2. 1 and 2. 3. 1 and 3. 5, 1 and 5, 7, 1 and 7, 11, 1 and 11. What about those composite numbers on the right hand side? 4, 1, 2, and 4. 6, 1, 2, 3, and 6. 8, 1, 2, 4, and 8, 9, 10. Now what do we notice? What we can see is that prime numbers only have 2 factors, 1 and itself. Whereas on the right hand side, the composite numbers, they have more than 2 factors. A really smart guy called Eratosthenes discovered an easy way to determine prime numbers. When considering primes over 5, a number is prime when it ends in 1, 3, 7, or 9. And at the same time, it cannot be divided by either 3 or 7. This is where we need to know our divisibility rules. So take, for instance, the number 73. The sum of the digits 7 plus 3 is 10. Is 10 divisible by 3? No. So 73 is not divisible by 3. At the same time, 73 is not divisible by 7. So we know that 73 must be prime. Let's take another value, 107. First, is it divisible by 3? The sum of the digits 1 plus 0 plus 7 is 8. Is 8 divisible by 3? No. What about 7? Does 7 go into 107? Well, I know that 7 multiplied by 15 is 105, which is close to 107, but not exactly 107. So I know that 107 must be a prime number. Progress check. Using our 2 rules for prime numbers over 5, test and see whether these values on the left-hand side are prime or composite. 25 does not end in 1, 3, 7, or 9, and for that reason it is composite. 56 does not end in 1, 3, 7, or 9, it is also composite. 71 ends in 1. The sum of the digits is 7 plus 1, 8. Is 8 divisible by 3? No. So it is not divisible by 3. Is 71 divisible by 7? No. So we know that 71 is prime. 89 ends in a 9. Now, is it divisible by 3 or 7? The sum of the digits 8 and 9 is 17. Is 17 divisible by 3? No. Is 89 divisible by 7? No. So again, we have a prime number. 123. It ends in a 3. It might be prime. Is it divisible by 3? The sum of the digits 1 plus 2 plus 3 is 6. And 6 is divisible by 3. So we can say for sure that is composite. 131, that ends in a 1. It might be prime. Is it divisible by 3? The sum of the digits 1 plus 3 plus 1 is 5. Is 5 divisible by 3? No. What about 7? Does 7 go into 131? Well, I know that 7 multiplied by 20 is 140, and 140 minus 7 is 133. So we know that this must be a prime number. Lastly, 142. ends in a 2. It does not end in 1, 3, 7, or 9, so it must be composite. So we have now learned a simple trick to determine if a number is prime or composite. Remember as well, prime numbers only have 2 factors, 1 in itself, and composite numbers have more than 2 factors. Hey guys, this is Casey at Onetree. If you like the content, please remember to like and subscribe. Also, if you'd like some online tutoring, please email me at onetreemath@gmail.com. Cheers.